Hey, Ruta, here's your video. I gotcha. My goodness, leave me alone. Just kidding. Good morning. I have been up for an hour. It's now 5 o'clock. And I definitely have my Dunkin' Donuts coffee. But I've been farting around on my computer for so long because I hadn't used it in a while. My coffee's cold. Now I'm not very happy. But this will make me happy. Oh my God, this is so much fun. So, I don't know if you know, my first set class has a couple of young boys that are sort of annoying. Really like them a lot, but they're kind of annoying, if you know what I mean. So I found them some seats. We're going to have to use this in class. Here we go. There we go. Look at those boys. I don't know if you can read it or not. I'll read it for you because, you know, it's got some emphasis on some words, you know. It says, "Hey, Joey, where's Jackson? We found him a sweet chair for class." I don't know, Jack. Probably going to the bathroom. This math is hard. Sorry, Jackson. Didn't have a picture of you, but there's your sweet seat. You are the winner of the purple throne of goodness. I don't know what you call it, but boys, we're looking for some seats. Anybody out there? Do we see these on the side of the road? Would you pick them up for me, please? Clean them off. Bring them to class. I got some chairs. We're going to put those in the front of the classroom. Oh, it's going to be glorious. Glorious. All right, let's get to work. I was just kidding, boys. Not. All right. Nick, the crazy cat guy, started with 5 cats. You know what I didn't do? I didn't get my calculator up. Probably ought to do that. Is that this thing? Hopefully that's it. Yeah, that's it. Crazy cat guy started with 5 cats. And his parents told him, he told his parents and his friends not to worry. They're only tripling every 4 months. If this is true, how many of these cats would he have after 5 years? Well, let's see. We'll start with A of T. We'll start with 5 cats. They're just tripling. No big deal. You know them cats. But they're tripling. Here's the word. Where is it? Where is it? I got to find it. Where is it? Where is it? Where tripling every... wow, it does not like my highlighter. There it is. Every 4 months. Hope we don't do that all day long. So remember, when it's every, you're going to have a fraction as your exponent, right? Every 4 months. Now, look what I did here. Years, months. You cannot mix and match units. So I got to convert this to months by multiplying by 12 and get 60 months. So I'll do 60 here. And there we go. That's it. So we're going to have 15 triplings. Not a big deal. Calculator, and we'll go 5 parentheses, 3 parentheses, raised to the control division, 60 divided by 4, and we've got, oh, son of a so-and-so and such and such. 60 over 4. Bam! 71,744,000. 71,744,535. All right, so I just have one thing to say. Get your cat spayed or neutered. We don't need 71 million cats, Nicholas. All right, Victoria and Desiree are having a fight about who will have more of their nasty and smelly animals called lions. After 1 year. Did y'all miss the 1 year right there? I snuck her in. Victoria started with 200 of these awful, disgusting, hairy things. She says the food she developed will increase these by 17% every 4 weeks. So let's see. We'll do Victoria over time. She has 200. They are increasing by 17%. So we're going to do an increase. 1 plus 0.17. It's an every, so we're going to have to divide. We're going to have to divide by 4 weeks. So you can either have this, 52 over 4, which is really going to give you a slightly different answer. And I know my answer key probably has something slightly different than what you did. Or you could do this. 1 plus 0.17. And then, oh yeah, and then 365 over 28. Either of these would be acceptable. This is the number of days in the year. This is the number of days in 4 weeks. This is the number of weeks in a year. This is the number of weeks. Now, this is the more accurate because 4 weeks has 28 days and there are 365 days in a year. There are, I don't know exactly, I don't think there's exactly 52 weeks in a year. Maybe there are, I don't know. But you're going to get slightly different answers. Let's see what we get. Where's my calculator? Where's my calculator? There she is. Oh, let me stop. I haven't used this in a while. See how things are going. Oh, forgot where we were. I was just going to check things out. All right. Oh, we got to go to calculator. Oh, we're going to the calculator. I didn't know what I'm doing. There. Oh, there it is again. Oh, my God. They're crazy. All right, let's do this. We don't need you. Get off my screen. All right, so we got 200, parenthesis, 1 plus 0.17, parenthesis, raised. Now, this is going to be a fraction, right? Wasn't it a fraction? And we're going to do the 365 over 28. 148.39. So in this case, because these are lions, we can only have 148. God bless it. How do I get back to this? All right, 148. So this is, I don't even know what it was, 1548. All right, now let's do Desiree. Desiree of t is equal to, what is she starting with? 20. And she's increasing by 20%, so 1 plus 0.20 raised to the every 15 days. So we're going to have to use 365 divided by 15. And we'll go back there. And you know what? This is close enough. Let's just do this. Now, she started with less. She only started with 20. Will she end up with more? Let's see. Oh, she does. 1689.56. So we'll go with 1690. So she's going to have 1690. And the question says, and you got to be out, who will have more and how much more? So we're going to have to take this and subtract off this. And we end up with about 141. Boy, I thought it was going to be 142. Oh, wait, hold on. She had 1690 and subtract off. Here's where we got problems with the rounding. 1690 minus 1548. Yeah, this should be 142. About 142. Desiree, Des will have more lions, about 142 more. Wow, that was some terrible English. Terrible. All right, let's go. This one says, how would you know the difference graphically between the following two functions? And I should have said, can you figure this out without actually graphing it? Because the only difference is, let's see if blue will highlight. It doesn't like any highlighter. The only difference is the fact that this one has a 7% growth, and this one has a 70% growth. And you guys have been around in class now. You know there is a huge difference in just a couple of percentages. So, yeah, I'm not going to write this down, but yes, I would know the difference because this one would go up rather slowly because it's only 7%. But because this one is 70% growth, this one's going to shoot up really, really fast. This one is going to have much faster growth. And if you were thinking about your money, you'd be a millionaire by the time you were out of diapers. This one, you'd be a millionaire by the time you're retired. Big difference. Huge difference. Okay, some of you will still be in diapers before the 70%. Never mind. Just kidding. All right, let's move on. This should have been M. Sorry about that. So let's see what we got here. Ding, 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 ding. So this is J of M. And we want to know what M value will give us that. So we got to plug it in right here. So we're going to take $1,205.5. And we're going to multiply. We're going to set that equal to 7 halves. 7 to the 2/3 M. Now, as soon as I see this up here, I know that this is going to have to be a log function. In order to solve it, I'm going to turn it into a log because of coffee. Not because, oh, it's so warm or cold. Not because of coffee, but because when the variable is an exponent, we know we're going to have to turn it into logs. Well, the first thing we got to do is get the weird thing alone. So I'm going to get the weird thing alone by getting rid of this 7/2 right here because it's annoying me. So we're going to multiply by 2 7s. 2 7s. Notice this is multiplying. This is not raising to the reciprocal. We only raise to the reciprocal when we want to get rid of a exponent. That is a number. So 1200.5 times 2 7s. Good enough. 343. So 343 equals 7 raised to the 2/3 m. Well, now I've got the weird thing all by itself. I'm ready to log this. So I'm going to write log. Now remember, bases have exponents. I don't know why it's doing that. Bases have exponents. So this is my base, and this is my exponent. So log base 7. Now, logs are equal to exponents. So the exponent's going to come over here, 2/3 of m, and we're going to do log base 7 of 343. I still need to get rid of this nasty 2/3, so I'm going to multiply this side by 3/2, and I'll multiply this side by 3/2. And that's what I'm going to type into my calculator. I should have gotten rid of these. So that's what I'm going to type into my calculator. I typed 3/3 again over here. 3/2. That's ridiculous. So, control division 3/2. Wow. 3/2 log base 7 of 343. And you get 9/2. Your calculator probably popped up 4.5. So m is equal to 4.5. 9/2 is the same answer. Alrighty, we're moving. Oh, inverse. You see this word inverse here? I'm afraid to highlight it. Inverse. Inverse, we're going to have, anytime we have an inverse, we're going to have 2 steps. The first step, switch x and y. Second step, solve for y. Solve for y. So, you still got to switch x and y. Those go. That goes there. That goes there. And that goes there. All right, so we're going to switch. So we're just going to simply write x equals log base 5 of y. Now, because I have a log, I am going to turn this into an exponential by doing, okay, it's all about that base. All about that base. 5. Logs are equal to exponents, so there's my new exponent, and that's equal to y. And this would be the inverse. Now, you should be able to check these answers. Check it. Come over here. Go over to graphing calculator. Go into graphing mode. And we'll graph log of, log base 5. Log base 5 of x. Enter, Shabamarinsky, and then we'll press tab, and we'll do 5 raised to the x, Shabamarinsky, and we press tab, x, enter. They are reflections over the line y equals x, so they have to be inverses. Inverses are reflections over the line y equals x. All right, so this one shouldn't have been too bad, although there was one extra step in this one. First we do is switch x and y. All right, if it looks a little different, it's because I did that whole problem and I switched x and y and made it x and x. So I thought that was kind of confusing. So I thought I should start over. So we're going to switch x and y. Y goes there. X goes there. So we're going to write x equals, let's see if I can do this right, 1/2 times the log base 3 of y. All right, so we do have one little extra step here. We got to get rid of this nasty little 1/2 first. So we're going to multiply this side by 2, and we're going to multiply this side by 2. On this side, if I multiply by 2, they kind of go away. So I end up with 2x equals log base 3 of y. Now I'm ready to turn it into an exponential. It's all about that base, My base is 3. Logs are equal two exponents. So my exponent is 2x, and it's equal to y. And again, you can graph this and check it. Let me get rid of this. I graph this and check this. The first thing, I'm going to do 0.5. That's the same as a half. Was it log base 3 of x times log base 3 of x, shabam. And then I'll press tab. And then I'll say, what do we got? 3 to the 2x. 3 raised to the 2x. Oops, somehow we got a Q in there. 2x. And press enter. And if you tab, x, they are again inverses because they're reflections of the line y equals x. So you can check it graphically. All right, so this one should have been one thing. I'm going to do it the mathematical way first. Here we go. I'm going to do this the mathematical way first, and then I'll show you the calculator way. Mathematical way is to say, okay, turn it into an exponential. So 5 raised to the x equals 3125. So I can come over to my calculator and go, okay, 5 cubed? Nope. 5 to the 4th? Nope. 5 raised to the 5th? Yep. Or I can simply just type it in. Control log base 5 of 3125, and I get 5 directly. So the answer is x equals 5. This one, again, you can just type in. I'll do this one mathematically, and then I'll show you calculator. The base here is 10, so 10 raised to the x is equal to 10,000. Well, you should know that is 10 to the 4th power, so x has to equal 4. 10 squared is 100, 10 cubed is 1,000, 10 to the 4th is 10,000. Or you can just type it in, control log of 10,000. My goodness. Four. All right, that one's done. Oh, I can't do that, huh? All right. Given the following function, state the domain and the range. Okay, so this is a log function. Let me just remind you what the log function looked like. The log function looks like it goes through the point 1, 0, and it grows slowly. And it also approaches the x-axis without crossing it. So in this case, my asymptote is the line x equals 0. However, we are moving 6 units to the right. So instead of x equals 0, 1, 2, 3, 4, 5, 6. Now my asymptote is going to be here. I moved my asymptote over there. That was funny. And we're going to grow up like that. And we're going to approach this. So my domain in this case is going to start at 6 and it's go to the right to positive infinity. My range, on the other hand, it didn't change. It goes up and down for evers and evers and evers and evers. Negative infinity and positive infinity. All right, before I do the next one, try it on your own. Try it on your own. I said try it on your own, boy or girl. Or whoever's looking at this. Mr. Krause is a bit cuckoo. I'm not going to graphically show this one. I think you guys get it. Domain. By the way, if you don't write the word domain or at least D, you lazy bums, then I'm not picking. I will pick wrong every time. So the domain, we moved to the 5. We moved left 5. That means we're going to go to negative 5 to infinity. Notice it's a parenthesis, because that is now an asymptote that you're not allowed to touch. This can't touch this. Can't touch this. I know what you're thinking, Mr. Krause. You got to stop drinking so much coffee. No? You were thinking my talents would take me far? God, I want warm coffee. All right, here we go. Woo! Look at these babies. They look like fun. Yeah. Remember, you can always check these by storing some obnoxious number into m and then just typing this in. But we're going to do it the right way. Whenever you divide, we're dividing here, we are going to subtract the exponents. Now, if you can't do this in your head, that's okay. I'm going to do it in my head. You can go to your calculator and go, oh, calculator, 2 divided by 3 minus 7 divided by 3. Enter. Oops, didn't tell you what it was. But your calculator would pop up negative 5 over 3. And we're going to raise that to the negative 6 over 5. By the way, it did say negative 5 over 3, didn't it? No, yeah, it did. So now what do we do when we have an exponent raised to an exponent? Well, when we have exponents raised to exponents, we multiply those exponents. So we get m to the 30 over 15, which is really just m squared. There's your answer. And again, if I want to check this, I'll show you one more time how to check this. Let me get a fresh screen here. I don't know why that thing has problems over there. So no, I can just take some obnoxious number, 2.368, and stow it into m. And we'll start with a bad fraction. Oops, I should probably start with some parentheses. And then a bad fraction. And then we got m raised to the 2/3, right? I'm only doing this once. 2 divided by 3 all over m raised to the 7 divided by 3. I don't know why I have... Wait. I don't know why. Control X. I should have parentheses. I don't know why. I can't use brackets. That's a problem. So m raised to the 2 divided by 3 over m. I hate doing this stuff. Raised to the... But if you want to know if you got it right, I mean, this is a clear indicator of whether or not you got it right. We're going to raise this whole thing to another fraction, which was negative 6 divided by 5, wasn't it? I believe. And we get some obnoxious number, and then we take our answer, which was m squared, and we type that in. Or we type in m squared. And I did something. Oh, gosh bless it. Look at this. I always make some dumb mistake. Did you see it? Probably saw it when I did it. 3. So, do you notice they're the same? They're the same. Easy way. Okay, I'm done with that. I'm not doing that again. That's too much work. But, if you want to know if you got it right, go ahead and check it. All right, we're going to subtract these. 2 is really just 8 over, 10 over 5. I need to have a common denominator. Again, if you can grab your calculator and subtract these. But if I do, I get d to the 6/5. We're going to raise that to the negative 3/4. And what I end up with is d to the negative 18 over 20. But that can be reduced to d to the negative 9/10. But I said write it with no negative exponents. And since I have a negative exponent, I got to throw that into the denominator. So it becomes 1 over d to the positive 9/10. And there's your answer for that one. All right. Okay, we're almost halfway there. Taylor. Taylor started out with 12 rabbits. Okay. That was a pretty good interpretation. She noticed that they were growing at a rate of 12% every 21 days. How many rabbits will she have at the end of the year? Okay, this one's similar to the one at the beginning. I don't know why I put these on again. So, rabbits, the rascally rabbits. Rabbits of Taylor is equal to 12. They're increasing at a rate of 12%, so 1 plus 0.12 raised to the 365 over 21. Remember, this is our every. And we'll grab that calculator. Get off my screen, you pain in the neck. My goodness. So, 12. I probably should clean this up because it's a mess. 12 parenthesis 1 plus 0.12 parenthesis raised to that there 21. Nope. 3065 divided by 21. But damn, 86 rabbits. So she will have 86 rabbits. Damn rascally rabbits. AJ bought a 1969 Chevelle SS. By the way, that is one sweet, sweet, sweet car. And put a ton of work in it. We had the praise on January 1st, 2015 for $18,500. However, the appraiser told him that would appreciate at a consistent rate of 7.5% every 6 months. What would the car be value be at the end of this year? So, value over time is going to be equal to 18,500. Now, it's increasing at a rate of 7.5%. So we're going to do 1 plus 0.075. Now, this is the hard part. It's every 6 months. Okay, so that's our every 6 months. But I can't use, what's my time? Did you figure the time out? Because I put it in there kind of cryptically. Did you get it? I said that he had it appraised in 2015, and then I said at the end of this year. This year is 2018, so that would be 3 years. And 3 years equals 36 months. So I need to put 36 up here. That's 3 years. Okay, and I said at the end of this year. This year is 2018. Ha ha! Trick ya! Oh my God, I love tricking kids. 18,500 parenthesis 1 plus 0.075 parenthesis raised to that there. I don't remember. 36 divided by 6. Can we just put 6? $28,551. So it would be worth $28,551.08. Hopefully I get these right. Oh my goodness. There's a very strange compound when known as an Anya Freakawini. The Anya Freakawini has a half-life of 8 years. Way too long if you ask me. That there Anya Freakawini started at 110 pounds. Got 120 pounds of that obnoxious substance. How much are we going to have in 20 years? Well, hopefully none, if you know what I'm saying. So, A of T, doesn't matter what we call it. We're starting with 110 pounds of this obnoxious whiny, but it's got a half-life of 8 years. So, okay, wait a second. Half-life means it's getting half of its amount. Half of its amount. And this is my every 8 years it decreases by half a life. So we got to divide by 8. Remember, the denominator is my every. Every time it happens, every 8 months, that goes in the denominator. And we're doing it for 20 years is my time. So this wasn't too bad. See how much of this Anya Freakawini we have. 20 parenthesis 1 divided by 2 parenthesis raised to that there 20 divided by 8. And make sure it looks pretty over here. You know, look at it. Is this what it looks like when you wrote it? That looks like what we look like, right? That doesn't look like what we look like. Oh my gosh, I forgot I got a weird calculator. Let me do this. My calculator will give me the strange answer. There it is. 3.5355. What do we say we got to round to? Round answer to the nearest tenth of a pound. So we will have 3.5 pounds. I hope I'm getting these right. Did I put this in right? Oh my goodness, no I did not. Oh yeah, I did. No I didn't. Why did I put You guys thought you had bonus. I gotcha! Oh my God, Mr. Krauser fooled you. Of course we should. I knew that it was a little bit too little. Didn't make sense. We should have 110 pounds here. And that means we have 19.4 pounds of Miss Anya Freako whininess 19.4 pounds of the freakiness. Sorry, kid. I had you only at 3 pounds. That would have been like Ant-Man. Alright. I just spent the last 20 minutes trying to figure out why my camera didn't work. Oh my gosh. That's crazy. Ruta! You're welcome. You better get 100 on my test or better. Or we're fighting. Alright. Let's do this. Now, we have a log function. In order to solve a log function, we got to turn it into an exponential function. All right, and it's all about that there base right there. Now, logs are equal to exponents. There's my exponent. There's my base. It's all about that there base. One more day and listen to that crazy song. So 5 cubed is equal to 2/3 x minus 5. That's it. Well, of course, you got to solve it. 5 cubed is 125, so we get 125 equals 2/3 x minus that there 5. Bring the 5 over, we get 130 equals 2/3 x. Multiply by the reciprocal, and I get 195 equals x. Now, I know you probably used that there calculator. Don't forget, all this stuff can be checked, right? 195, control var x. Shut up. X. And then, type it in your calculator. Log base 5. Control log base 5 of 2/3 x minus 5. Boom. Equals 3, equals 3. We're done. It doesn't take that long to check. All this stuff can be checked. Let's do this one. 2 cubed equals 3/4 x minus 8. Bring the 8 over. Oh, excuse me. 40. This is 8. So I get 8 equals 3/4 x minus 40. Bring the 40 over. You get 48 equals 3/4 x. Multiply by 4/3. Multiply by 4/3. Let's see. 3 goes into 48 16 times. 16 times 4 is 64. So 64 equals x. Moving on, children. If that equals that, well, this is too difficult to deal with. So what we're going to do is we're going to change that into b. Don't forget, this is the exponent, this is the root, this is the denominator. So 12 over 5 equals a to the 3 over 10. Now state a in terms of b. In other words, we want to solve for a. So we got to get rid of this 3/10. Now we're going to raise it. We're not multiplying. We're going to raise it to the reciprocal. 10 over 3. 10 over 3. Well, if we do that, these go, and these go. So I end up with a equals, let's see, 5, 2, 4, 8. B to the 8th, I think. 12 over 5. Let's see. Goes in there twice. Goes in there 4 times. B to the 8th. There it is. Or you can just grab your calculator and go, okay, I don't know, 12 divided by 5. Probably should put that in parentheses. Parentheses. Times 10 divided by 3. Parentheses. Parentheses. 10 divided by 3. Enter. 8. So b to the 8th. All right, moving on. Same kind of an idea. So p to the 9/4 equals q to the 3/2. State q in terms of p. So again, we're going to solve for q. Or in this case, we're going to solve for q. Raise it to the 2/3. Raise it to the 2/3. 3. Ooh, this one's going to be a little bit different. This goes in here twice. This one goes in here 3 times. So the q is equal to p to the 3/2. Bam, bam. Moving on, children. Oops, this one I'm in the graph for. Okay. Get off my screen. Get off my screen. My guess is most of you are going to mess this one up, and I hope you didn't. First thing, I forgot to make the change. This should be a 3, not a 2. Makes it a lot more simpler to do. This is the important part, all the relevant information. Usually they'll tell you what to put. Sometimes they'll be vague like this, that they want the relevant information. Well, relevant information are usually x-intercepts, y-intercepts, and scale. Now, if the scale's just 1 by 1, you don't really have to put that in there, but if it's not, you have to put it in there. And you're going to find this one's a little tricky. You better know how to do this on Monday. I'm telling you right now. So what we're going to do is we're going to go over to our graphing calculator. We're going to graph this thing. So it's log base 3. So log base 3 of x plus 3 minus 3. Well, what don't you see? I don't see my x-intercept. I can clearly see my y-intercept, but I don't see my x-intercept. So I want to change this number over here. So maybe I'll make it, I don't know, 30. Is that enough? Oh, it's barely enough. Okay, so 30, I can see it, right? I don't know exactly what it is, so I'll go Menu, Analyze, Graph. Now, again, this is why if you chose 2, it wasn't very pretty. So I'm going to choose 0, click, and click. And it looks like my intercept is 24, 0. And that's important. Now, this y-intercept, this looks like it's 2 here. I can go in the table, Control-T, and see that at 0 we get -2, and we do. So what do I want to do? The relevant information is this y-intercept and this x-intercept. So the problem with it is my graph here only goes to 10. So I've got to change that. So what I'm going to do is I'm going to fill this box in. I don't care about up and down. I'm going to maintain that as 1, but I'm going to change this to 3 because 24 is a multiple of 3. So 3, 6, so 3, 6, 9, 12, 15, 18, 21, 24. Oh, my y-intercept was negative. My y-intercept was -2, but I also need one more thing. I need one more thing, and that is my, I forgot to write this down, my asymptote. What is my asymptote? Well, this thing moved to the left 3, so I need an asymptote at -3. Now, it's important that you write this because some kids, most kids, there's going to be a bunch of them on Monday that don't watch this. What they're going to do is they're going to do this. They're going to go, oh, okay. They're probably going to not even do that and just go like that. And that's not acceptable. Totally not acceptable. You're not allowed to go over this this asymptote right here. So you're going to draw that down like that. You're going to come over here. You're going to go through the x-intercept. You're going to try to go through that x-intercept and then draw it. And that would be an acceptable graph. You drew an x. You have the asymptote. You have the x-intercept, and you have the y-intercept, and you get a real good picture. That is the relevant information, and that's what you need. Okay, let's move on. Some of you just learned a definition, I think. All right, let's look at this one. Using the formula below, determine the monthly payment of a 7-year loan with an annual percentage rate of 4.5%, and we're going to do a down payment of $1,500. So the first thing we're going to do is figure out what we're going to borrow. So we're going to take $41,000. 41, 1, 2, 3, and we're going to subtract off $1,500. So we got to take a loan out for $39,500. Number of pay periods. Well, it's 7 years times 12 months, so that's 84 pay periods. I don't know what my payment's going to be, but my monthly interest rate is 0.045. Now, that's my interest rate. That's my I. All right, so we're going to do $39,500 equals the payment one minus 1 plus. Now, because this is a yearly interest rate, annual percentage rate, I got to divide by 12. Man, that is terrible. Over 12, raised to the negative 84, all over 0.045 over 12. Now, all of this is just numbers, so we'll type that into our calculator. Control division, 1 minus parenthesis 1 plus control division, 0.045 over 12, all raised to the negative 84, all over control division, 0.045 over 12. Hopefully you got that typed in there. A lot of you are going to forget that negative. You're going to get screwed up. So 39,500 equals PMT, 71.94161116112145. So we're going to divide by that, 71.9416112145, right? 71.9416112145. So we're going to take 39,500, we're going to divide it by this, and we get $549, and careful here, 6 cents. So my payment is going to be $549.06. So if Fast Eddie can only afford $500 a month, what down payment does he have to take? Well, okay, so what do we know now? We now know that he can afford this, but none of this here is going to change. No, oh, look, it's not going away now. None of that's going to change. All of that's the same. That's an 84, by the way. So really what we don't know is we don't know what this loan amount's going to be. So that's the thing we got to figure out. P of N is going to be Fast Eddie can only afford $500. And we're going to plug that baby back in there. 71.9416112145. All right. So 500 times, so he can afford $35,970 and 81 cents. But that's not the question that they ask. The question asked is, oh, this should be car. Did I say house? This should be car. The question says, what down payment does he need? What down payment does he need? Well, we got to take 41,000, and we got to subtract off that answer, and he needs the $5,029. So his down payment has to be $5,029.19. How'd you do? Are you doing okay? All right. Okay, let's see what we got. We got Mr. Brooke Gay ran an experiment where the size of the compound was growing at 22% per month. They started the experiment with 8 pounds of the compound. 8 pounds of the compound. Say that 10 times twice. Write a recursive rule. A recursive rule always has 2 steps or 2 lines. First one is a sub 1. Very simple. We're going to start with 8 pounds. Boom, done. Now what are we going to do to that? All right, what we're going to do to that is a sub n. We're going to create a rule. We're going to increase it by 22%. So we're going to take 1.22. You could, if you wanted, to write 1 plus 0.22. It doesn't matter. Either way is acceptable. I'm just going to stick with this. So 1.22 times the previous term. Well, the previous term is just simply a sub n minus 1. And that's it. Ka-ching, done. Define the growth for explicit rule. This one we're going to use the geometric sequence formula. And that would be right there. Right there. So, what's that rule? That's going to say a sub n equals your starting amount, which is 8, my growth factor, which you can write 1 plus 0.22, or you can write 1.22. It doesn't matter. Raised to the n minus 1. That's it. That's all she wrote for that. All right. The last question says, use both functions to determine how much of the compound there will be after 6 months. Rounds answers to the nearest hundredths place. All right. Well, recursion's kind of a pain. We're going to start with 8. We're going to go a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So, it's easy on the calculator. Let me clear out all this stuff. And then we're going to go 8, enter. And then we're going to say times 1.22, because that's what we're going to do. We're going to multiply by 1.22. So this one we get 9.76, and I should probably show my work. 1.22 times 8 equals 9.76. Don't round. Oops, this one's easy. Next one's going to be 11.9072. So 1.22 times 9.76 equals 9072. Can't round. Now we're going to take 1.22. We're going to multiply by 11.9072. And I should have probably picked less. 14.5267. 14.5267. 84. Don't round. Oops, Control Z. Now we're going to take 1.22 and we're going to multiply that by 14.526784, and we get 17.72267, 648. And finally, 21.62. It says round to the nearest hundredths place, so we're just going to write 21.62. 21.62. So that's using recursion. Using the explicit formula, we can go directly to it. 8, 1 plus 0.22, or you can write, I'll show you the same thing as 1.22, raised to the 6 minus 1. All right, 8, parenthesis, 1.22, parenthesis, raised to the 5. Same exact answer. Right there, 21.62. Done. Finished. Hey, there she goes. We got 2 left. Woo! All right. Now, you could do these 2 different ways. This one, if you wanted to, you could do it. I'm going to show you 2 different ways. You could go 9 to the 3x squared minus 5x plus 8 equals 9 squared, because this is 9 squared. But what was already there? X squared minus 2x plus 7. Now that the base are the same, you can set those exponents equal to each other. 3x squared minus 5x plus 8 equals 2x squared minus 4x plus 14. The other way you could have done it is convert them to 3's. So 9 is 3 squared. What's already there is 3x squared minus 5x plus 8 equals 3 to the 4th x squared minus 2x plus 7. Now we don't need these again. We got 6x squared minus 10x plus 16 equals 4x squared minus 8x plus 28. Either way is acceptable. We're going to bring things to the left side. And if I bring things over here, I get x squared minus x minus, this is a 14, so minus 6 equals 0. And I'll factor to x minus 3, x plus 2, and I get two answers of x equals 3 and x equals negative 2. Over here, I'm going to bring everything to the left side. I get 2x squared minus 2x minus 12 equals 0. The only difference is, by doing it this way, is I now have a GCF that I should take out. 2x squared minus x minus 6 equals 0, and you end up with the same answers as over there. Now that sometimes works. I like to use 2, 3, or 5 as my bases, if I can. But in this case, I could have just simply used 9, or I could use 3. Now this next one, you don't have a choice. You have to use 2. You have to use 2. Because you can't turn this into a 4. 4 squared is 16, but you can't make a 4 into an 8. Not with exponents. Not with exponents. So what we're going to do is we're going to turn the 8 into 2 cubed. We're going to turn the 16 into 2 to the 4th. But what's already here? X squared plus 10x plus 1. What's already here? X squared plus 7x. Now I don't need the bases anymore. I just set the exponents equal to each other. So 3x squared plus 30x plus 3 equals 4x squared plus 28x. Now since this is my highest exponent, I got to move everything to that side. So 0 equals x squared minus 2x minus 3. And I get x minus 3, x plus 1, and I get x equals 3, and x equals negative 1. You really, really, really should check these. Who knows if you screwed something up? Really simply should just check these. Oops, cancel. So I'm going to take 3 and store it into x. 3 control var Xorinsky. And I'm going to type in 8 raised to the x squared plus 10x, x squared plus 10x. This is going to be a ginormous number, plus 1. Your calculator probably put it in scientific notation. My calculator tells you what the whole thing is. The other side is 16 raised to the x squared plus 7x. X squared plus 7x. Either way, they should look about the same. It's like my salary from last year. And I can do the same thing with negative 1. Negative 1, control var x, enter. Type in the left side, get an obnoxious number. Type in the right side, hopefully get that same obnoxious number. Great test. Okay, kids, study, study, study. There's a blank copy of this in the Google Classroom. You should already have a copy of it. Do it again if you need to. Practice the problems you're not good with. Try them over and over again so you know exactly the technique that goes in solving these. All right, kids, good luck. 6 o'clock. Look, it only took me 2 hours to get the videoing done. All right, bye. Goodbye.